Here we are. Okay. So, we have been doing conversion problems. How are y'all feeling about conversion problems? We need some more practice.
Yeah, a little bit more practice.
A little bit more practice? Okay. Well, let's do a little bit more practice, and then we'll move on to the next set of objectives. All right, so I'm going to go to modules. Remember, there's a link to this website right in here. There's the lecture channel. So if you want to go back and look at one of our class periods, you can click on there and it'll take you to the channel. Just look under live. And let's go to conversion worksheet practice. All right. Let's do a few problems. Okay. US letter. This is randomized every time. So you get a new set of problems each time we work it. All right, let me get you guys to do the first 5, 1 through 5. So if you remember, we have, what is it asking? Our steps are. What is it asking? What is our plan? We set it up. And inside setup, we got our table, conversion factors. Then we've got cancel units. Then we've got multiply and divide. And then we ask, does it make sense? All righty. What else do we write? King, Henry. That's it, usually. There you go. Trying to help us remember that. Each step on the larger side, when you move from the next unit, that's 3 steps, not 1. When you go smaller, it's 3 steps, not 1. So we've got milli, micro, pico, and nano. Excuse me. Here we got mega, giga, and tera. Each one of these is 1 step. So 3 steps equals 3 decimal places. 1 step here is 1 decimal place. Our units are grams, meters, and liters. So even though a lot of this is already just in my head, I write it out. Let's get a sheet of paper out. Let's do the first 5 problems. I always write it out because sometimes my brain doesn't want to work. That's being human. It is okay if our brains don't want to work sometimes.
I'm going to learn empirical formulas anytime next week, probably.
Empirical formulas? You mean like converting from inches to meters?
No. I mean for chemical compounds.
You mean molecular formulas?
I'll know what this is empirical.
Okay, is this the knowledge check? Oh, this is homework too.
Yeah.
we haven't gotten to information on Unit 2 yet. Oh, empirical and
Insert the math numbers.
Yeah, so homework 2 goes with Unit 2.
Okay.
Mhm. It's okay to work ahead.
Don't worry about it though.
Don't worry about it yet. If you want to work ahead, you can. Just keep in mind, we haven't hit stuff in Unit 2 yet. But you are more than welcome to work ahead if you want to. But we're still in Unit 1. I'm gonna quietly start to set up the first one. Okay. Oh, sorry. Milligrams, grams, not. There's my grams there. 3 steps, right? Freeze, that's more like that. So I'm going through and labeling my steps too in my setup. So I've set up the first one and gone through and worked it out, just in case we need a refresher. What is it asking? I'm converting milligrams to grams. I'm just writing it out. What's my plan? Well, I'm gonna convert milligrams to grams. There's 3 steps between those two, right? So I made a note of that. Then I set up my table. I put what I'm given in that top left corner. I'm converting from milligrams to grams, right? Then I gotta cancel my units, where I'm left with just the unit I want. Multiply across, divide, and get my answer. And then I ask, does this make sense? Yes, I should have a smaller unit. I should have a smaller number or a larger unit. Now, if this was milligrams and not grams, I should have a larger number for a smaller unit. Y'all see what I did? Kinda. So, where things could go wrong. We're gonna check our answers here in a minute. So as you're looking through and you're like, how do I make certain I don't mess up? There's different questions you can ask. All right, so your plan is the plan on top of the table. Is your plan on the top of the table? So my plan is milligrams to grams. My plan is literally on the top of that table. So if I'm going milligrams to grams, I should have milligrams to grams. My plan is on top, the top of the table, right? So that's one way you can avoid making a mistake. Another mistake, does the larger unit have 1? Does the larger unit have the 1? What happens if I put a 1 here and 1,000 up here? You get a really long number, right? So I always just I just try to remember, I'm going to give the larger unit the 1. I just do that default in my brain. All right? Number of zeros equal to steps. Now keep in mind, as we get to the larger steps, each one of these represents 3 additional steps, not just 1. So if we were converting from kilo to mega, that's 3 zeros between those two, not just 1. That's another spot. Are your units diagonal? Cancel units. Are canceled units diagonal from each other? The largest amount of time it should take you to do one of these problems is the setup. These are the questions that you ask when you set it up. And I know this is like, Ms. Williams, I could just move the decimal point, but when you're dealing with derived units where you're multiplying units together and dividing units together, like density by itself is grams per liter, you're dealing with multiple units, you're gonna have to keep up with where they are. Otherwise, you're gonna get a really wrong answer. So I teach this method from the beginning because it keeps you from messing up, right? And the more practice you get with the easier problems, when you get the harder problems, you would have already done this 100 times. You know what I mean? This becomes faster the more you practice. Kind of like an instrument. The more you practice, the better you get at it. That's just how it is. So think in this way. All right, y'all ready to check your answers? Let's have a look. Here you go. Boom, we did good on that. How did y'all do with milliliters to liters? Fill in what you need to. You need to take a picture of it, you can too. Yes.
For number, I think it's for number 5. Since the meters is smaller than the kilometers, we still need to put the 1 with the kilometers.
Yep.
Since it's larger.
Kilometers, that's large in the meter, so you put the 1 there.
Okay.
There's also a potential trap. You're thinking smaller is on the bottom sometimes, right? Smaller can be on the top sometimes. Can be on the bottom sometimes. Don't fall into that trap. Your plan goes on the top. Smaller isn't always on the bottom. Sometimes it's on the top. So the way to go about that is rather than go larger numbers always on the top, maybe when you make your table, think about it this way. What I'm given, so this unit and this unit are going to be the same units.
That's all I think about it is, so I start with kilograms and then I automatically put kilograms in the next box on the bottom.
Convert from this, convert to this. So your plan, whatever you're converting from, what you're starting with, convert to. And what you're converting to. So I try, that's why when I go through on the steps and I go, what's my plan? I write out what I'm gonna do. If I have to do like multiple steps, if I'm going to picometers, you know, if I start out with meters, then I'm gonna go to picometers. I might hit a millimeter in the middle, and then I hit picometers at the end. My plan is always gonna fit on the top. So don't fall into that trap thinking that one particular unit's gonna be always on the top or always on the bottom. Try to think about it as what I'm given, what I'm converting from, what I'm converting to. What I'm converting from, what I'm converting to. Try to put it in that perspective.
It's like, if you show the very beginning, put together, and the front, and then back, and then you have to convert to, that's what you're given again, that's why it's converted from.
Right, so if I was going from meters to micrometers, let's say that. Meters to micrometers. That's what it's asking me. I might go meters to millimeters, then to micrometers. I might have multiple steps in my conversion. Then what that would look like, meters, millimeters, micrometers. I put my plan on the top. I'm converting from meters to millimeters, from millimeters to micrometers. Try to frame it in that perspective. Your plan is always going to fit right on the top. That may take a minute. That may be a concept I was at 11 marinate. You know, does that help?
Yes, ma'am.
Okay. I mean, that's a good question. Okay, so here we've got days to hours. Y'all might can do that in your head too, but it's nice to set it up to where we have it going like this. Let's do the next 5. Liters to milliliters, hours to seconds. Here's one where you might have multiple steps. Maybe you want to do hours to minutes to seconds. You know, hours to minutes to seconds, right? So that's your plan. You go on the top. Let's see how you do. I just want to remind you guys, a lot of this stuff is hard. It's okay if you don't learn everything all at once. I hated chemistry for a long time because I didn't know how to do it so well. You don't have to love it either, it's okay. I'm not gonna get mad. I'm pretty chill. Please don't let me take physics again. Although probably be better this time around. Physics one I did not enjoy. How many courses on the fully? Man, I don't care.
That's too much.
2 electrons moving in the field. That made more sense to me, and that required a distinct, huge amount of imagination. Oh, by the way, I think Sunday movies are $4 at certain theaters. Go see Oppenheimer.
Well, we'll be there tomorrow.
$4, man. See a nuke detonate. They actually detonated a nuke in that.
That's all they, that's
Should
all
be
they
the
did.
popcorn prices.
Yeah.
That's
See,
all they
I
did.
don't care about the movie TV.
see what you do is you make a friend that has a giant purse. I didn't say that.
Or they didn't actually drop a new, like, no, he got a whole bunch of, a whole bunch of explosives together. He didn't actually drop a new, he got a whole bunch of explosives together and kind of scaled it up a bit, made it.
But he had to get the military involved.
Oh, yeah, but it was an actual nuke, but he had help from the military.
Yeah. But it's cool. Is this making more sense for you guys? Look, well, so here's micrograms. Remember, grams, next one after milli is micro. So between milli and micro is 3 steps. So make certain you keep up with that one. That one's tricky. Number 9, potential traps. We'll be talking more about the nucleus, I think, in chapter 2, and radiation and all that, so that'll be interesting. And then when we hit the quantum mechanical model, that's when, Niels Bohr, we get into that, and Einstein, and Schrodinger, and Heisenberg, and Fermi's more of like quantum particles. Quantum particles, you like weird stuff, man. Read some stuff on quantum chemistry, quantum entanglement. Future is quantum computing. You want to ask a buddy, they got the same answer you did, that's all right. That's called peer review. You can talk to each other, see how you're doing with your problems.
I'm sorry.
What y'all think? Is it making sense, or do you probably need some more practice? See, when y'all gonna have temperatures, you just convert, you add 273 to Celsius.
How do you do that? 9 over 5 and 5.
Well, yeah, I'm not gonna test y'all in Celsius to Fahrenheit.
So you gonna count it off on a meeting over here, like on the homework, you give it a little bypass.
Yeah, so here's how I do homework and tests. Homework should be harder than your exams.
Oh, it is.
You hadn't had a test yet.
I know, but I just don't know any of them.
Okay, we're steadily working through the homework for homework 1. Your homework should be more challenging than the exams. That's by design. That's by design. My exams are very straightforward. There is only one answer to the question. It's not a whole lot of wordy questions. It is, there's this thing, what's the answer? There's this thing, what's the answer? It's just very straightforward. Homework will always be harder than your exams. And your homework is, is less of your grade than your exams are. So if you struggle in the homework, but you get through it, you're in a good spot. You're in a good spot. We ready to kind of check our answers? We got, give another minute. Oh, yeah, go ahead. Your homework will always be harder than your tests. Because, that's where you're putting the time in and the work. Follow the due dates in Alex. Follow the due dates in Alex.
Isn't that the bottom, like, when it shows homework and it shows the days of the week, it starts one and then a line goes all the way across to us into a certain date?
I think so.
Okay, that's the way I was confused is.
Yeah. I would just follow with due dates in Alex,
Okay.
not in Canvas.
Alex
Canvas
is
doesn't always update very well.
Alex is kind of weird.
It's very weird. It's very weird.
Did you check our initial knowledge checks?
Not yet.
Okay.
Not yet. What, the initial knowledge check? No. But it's useful to help you figure out what you need to work on as you move through the course. So the initial knowledge check, the whole purpose of that is to see what your current knowledge of chemistry is. If you don't know anything in the initial knowledge check, that's all right, because you haven't learned it in class yet.
Like 5% on the.
Yeah.
That's all right. You haven't learned it in class yet, right? So that's if you just happen to be adept at something within there, it'll show up, hey, you may not need to spend so much time on this particular area. So it might feel soul killing, but it doesn't really count against you. It's helped to cater the experience of the homework to your individual learning needs. That's all that is. All right, how do we do?
Oh, okay. Can be better.
So they did hours to minutes, then minutes to seconds. Yes.
Sometimes like number 6, it's like sometimes you have the unit on the top, but it's on the bottom there. How come it's sometimes switched?
What do you mean? Well, our plan always goes on the top.
Oh, okay.
So liters to milliliters, right? We're converting from liters to milliliters. That's why I try to put it in that context on the board with your plan on the top. If you don't quite process it all just yet, that's okay. Just keep revisiting it, and keep working on it. And then one day, maybe in grad school, I'll be like, boy, now I get that. That would have been handy like 3 years ago, That happened to me when I went to grad school. I'm like, this makes so much more sense now. Only took a few years, right? So that's just being a human being, guys. It's just being human. All right, so the link to this. If you want to practice, y'all need to have like dimensional analysis party, pizza party. Keep saying it, man. Somebody brings the pizza, y'all pull up the worksheets and you just power through, take random dance breaks, you know. It's all right. So I've got that right here. Your conversion worksheet practice, you just can click on that anytime you want. Generates a brand new worksheet for you if everything worked out.
That's gonna help a lot.
That's the goal, is to help out a lot. Okay, so let's talk about temperature. All right, I have a thing that helps me remember temperature. It's Celsius lives on 273 Kelvin Street. Celsius lives on 273 Kelvin Street. So sometimes we have to convert from Celsius to Kelvin because a particular formula, like the ideal gas law, it requires us to have temperature represented in Kelvin and not Celsius.
Don't you ever need to be using it?
I mean, if I had Celsius is 23.5 degrees, just add 273 to that and carry over the 0.5. Right? So I've got Celsius lives on 273 Kelvin Street. So for exams, it's Celsius plus 273 equals Kelvin. If the Celsius was 25.3, all you got to do is add 273 and you get Kelvin. So what is that? That is 8, what is it, 298? Well, that's a 0.3. So 3, 5 Kelvin. Yep. Did I do math wrong?
No.
Okay. I'm working on a lot of coffee. I should be doing that okay right now.
Wait, so does that mean like 1 degree Celsius is higher than 1 degree Kelvin?
No. Well, hold on. Yeah. So if I wanted to go and say if I had 372.1 Kelvin minus 273, that's going to give me Celsius.
Like Celsius is higher.
No, now we don't fall in a trap.
Like
0 Kelvin is absolute 0. Y'all know about absolute 0?
Not
Okay, so absolute 0 is where all movement of all atoms stops. Nothing's moving. Yeah. I don't know if we got there yet or not. So 0 degrees Kelvin is where it is so cold, there is such an absence of heat that there is no movement in atoms. Really cool thing I got to do is when I went to NASA and I was doing science communication work with them, I got to meet a Nobel Prize laureate, and his research was trying to get to absolute 0. And the device that he made, when he was trying to do it on Earth, the device that he made to test, atoms kept falling out of the container. So gravity was an issue in trying to get atoms to absolute 0. So he sent his experiment up to the International Space Station in a microgravity environment to see if he could keep the atoms within the device so they wouldn't fall out of the container because of gravity. See if he could get it cold enough to absolute 0. Y'all know that they constantly send experiments up there to the astronauts on the International Space Station to run stuff in a microgravity environment to see how that affects their experiments. Isn't that cool?
Do you believe they have that?
But astronauts? Yes. They're up in the International Space Station. They take pictures and send it back down all the time. You can look up the data from the experiments that they've done in there. They send supply missions. I watched a rocket at 3 a.m. at Wallops Air Force Base, Virginia, resupplied with all those experiments up there.
Question.
Yes.
So like, would NASA really have like rockets in people's lanes?
In people's what?
The lane like they do on the Transformers. When they like shoot up from the ground and like somebody farming or something like that. Is it like real life?
No. Transformers put me to sleep, y'all.
That's crazy.
Alright.
Some of the cartoon?
I tried to watch the first one like 4 times and it knocked me out every single time. Like, this is boring.
You just gotta understand what's going on before you
So, something's got to hold my attention. So, states of matter. The other thing I want to talk about real quick. What is states of matter? We're gonna talk. What is that?
Ice and
So, I have a question.
Solid, liquid, gas, plasma. Yes. What's your question?
Did you like Interstellar? The movie?
Oh no.
You did?
Why? Why?
They lost me. I mean, the black hole simulation is the closest thing to actual science that you can get. Everything else, I'm like, scientists would not do this. We would actually work to fix our planet because that would be cheaper than just shooting our DNA off into space and on another planet. It's just,
Seems
I
like
was
a
lost. I'm like,
Star Wars and Star Trek type of person.
yeah, I have to, I mean, if they say something is based on actual science, I'm gonna judge it harshly. So if you're like,
If they
Hey.
don't claim it's based on science, you just watch it.
I mean, I don't know, like Star Wars a long time ago in a galaxy far, far away. Okay, so physics isn't real. We already established that in Star Wars world. Okay. Light does not work that way. We cannot make lightsabers. I'm sorry. It just don't work that way. The energy required.
So once you get past it, it's not real. Can you watch it?
Yes.
Okay.
If it's not real, I can watch it.
There goes the movie.
So solid, liquid, and gas.
So as long as it's not pretending to be realistic. it's fine.
Yeah, don't tell me something, you know. All right. So these are things that we have to know.
I can understand that actually. I don't like being lied to, so I get that.
All right, mixtures. So we have states of matter, solid, liquid, and gas.
What about when like something goes super critical?
Are you talking about, I'll get to that with the
Okay.
gas. Okay, so plasma is ionized gas. So when we see lightning, we're seeing plasma because plasma can actually conduct electricity. So plasma is a state of matter that's not as talked about so much. But solid, liquid, and gas, these all have different relationships. I'm gonna pull up the simulation. Mixtures. We can have homogeneous and we can have heterogeneous. Mixtures are basically a mixture of different things. Homogeneous could be like coffee, milk, right? Homogeneous mixture, it's the same throughout. Heterogeneous could be like Rocky Road ice cream, it's got layers.
This coffee up to that, figured out, man.
Two F's. There's no, you know, I can spell DNA polymerase, so don't ask me to spell restaurant. Rocky Road ice cream, heterogeneous mixtures, like the ocean, because you got all kinds of stuff in there.
So wait,
It's got
Hold on.
layers.
I did the homework and it said it was a homogeneous mixture.
The ocean,
Yes. The
well, if
ocean?
we're talking about exclusively the liquid form, as far as just the water itself, yes, but we also have plankton in there that you can see.
On
We've
a
got
scale,
some-
it's heterogeneous.
Yes, if you're looking at the entire ocean with everything in it.
Cause it's got like fish and stuff.
Okay, same throughout is homogeneous. All right, I'm gonna show you guys a simulation that I like. You can find it here under resources. All right. So I like to look at this because it puts into context the importance of temperature, pressure, and volume when we're looking at states of matter. Okay. So we got a phase diagram here. So temperature and pressure are related to whatever state of matter we're dealing with. So right now we're looking at neon. So would you say that this is solid, liquid, or gas, looking at these atoms together?
That's a sign.
Solid. This is all solid. How can I get it to become a liquid? Heat. We add heat, right? I'm going to show you something really quickly. There's something called the triple point, where all three states of matter can exist at the same time. Did y'all know that? Solid, liquid, and gas can all be around at the same time. I got solid portions in the middle here. Liquid portions are on the outside, kind of sliding around. And then I've got gas. That's escaping. So at a specific temperature and pressure, all three states of matter can exist. Now, if I continue to add heat, I'm transitioning over to where it's either going to be liquid or gas, right? Liquid, we still got atoms sliding around each other. We have some that move to gas. Now, when we reach the critical point, we've added so much energy to this in the form of heat that we cannot differentiate between liquid and gas. They're just constantly changing. That's the critical point. So we talk more about this in general chemistry too, but things you need to keep in mind. If I were to reduce the volume of this, that's going to affect the state of matter. If I remove heat, that's going to affect the state of matter. If I reduce the pressure, that's going to affect the state of matter. Temperature, pressure, and volume all play a role in what kind of state of matter that we're dealing with. Okay? We'll get more into this with the ideal gas talk. So I'm just kind of priming y'all with coming events, right? Okay. Well, that's all I've got. Please work on your stuff. I'm going to